Hi, this is Mr. King. I'm an AB Calc teacher. Sometimes I teach some BC Calc topics when I have underclassmen who are still in school after the seniors have graduated. So for this lesson, which is on integration using partial fraction decomposition, which is a BC topic, of course, I've borrowed some examples and the structure of Mr. Corpy's guided notes document on this topic. He's organized and he's a good teacher. So I'm going to use these great examples. And just as an overview of the first section we're going to look at here, which will have 3 examples, we're going to look at and learn the heaviside or cover-up method. This is our easiest example. And in example 2, we're going to use a more general method involving equating coefficients. And in example 3, we'll extend that method where we will equate coefficients again. The whole idea in these problems is to take the integrand, which is a rational function in each case, and to write it as a sum of fractions where the denominators are linear factors. So let's go to the first example. Again, we're going to learn the cover-up method, also the heaviside method, because Oliver Heaviside, a mathematician, engineer, and physicist, came up with this method. It's very easy to prove why it works. I'm not going to do that here. I'm just going to demonstrate how you would use it. So first of all, we need the degree of the numerator to be less than the degree of the denominator to use this method. And in this example, we have exactly that. The degree of the numerator is 1. The degree of the denominator is 2. So the idea with this partial fraction decomposition method is we want to rewrite the integrand as a sum of fractions where the denominators are linear factors. And so the first thing we're going to do is write the factored form of the denominator, which in this case is x minus 3 times x plus 1. And the goal here is this. We want to write a fraction where we need to find the numerator and another one where we're going to put the other factor of x squared minus 2x minus 3 in the denominator, like this. So the question is, what is going to go here and what is going to go here? So here's where the heaviside method works really well. What we need to do are 2 main things. And the first thing is we'll note that x minus 3 is 0 if x is 3. So the cover-up method, we cover up the x minus 3. So we only leave x plus 1 and the 7x minus 13 like that. And then what we do with this is we let the x value of 3 go in for x. And we'll get 7 times 3 minus 13 over 3 plus 1, which is 21 minus 13, which is 8 over 4, which is 2. And that 2 is what we replace the numerator over x minus 3 with, like that. Now you can see here that the math is very simple, and this can be done as mental math, which means you can do the cover-up of the x minus 3 over here and just plug in 3 and do that in your head and then put the 2 in. For the next part of the cover-up method, we're going to figure out what goes over x plus 1. And the process is the same. I'm not going to write as much this time when we do this, but we're going to cover up the x plus 1. And when we do that, we take the x value of negative 1, because negative 1 plus 1 is 0. And now we put negative 1 in for x. So 7 times negative 1 is negative 7. Minus 13 is negative 20. In the denominator, negative 1 minus 3 is negative 4. So we have negative 20 over negative 4, which is 5. I just did mental math there. And so that's a 5. Now at this point, we're in a beautiful situation because we now know that 7x minus 13 over x squared minus 2x minus 3 can be decomposed into partial fractions. And so we're going to replace the integrand with this sum of two fractions with linear factors in the denominator. So let's do that now. And we're going to see that this makes this integral, which did not look too tractable at first, pretty easy to deal with. So the integrand is now 2 over x minus 3 plus 5 over x plus 1 dx. You can put parentheses on these if you want. I've always believed that the dx and the integral symbol capture those quantities, that summation, so the parentheses probably aren't necessary. And now we can integrate. And what we can see here is that 2 over x minus 3 will give us the 2 times the natural log of the absolute value of x minus 3. And we anti-differentiate. And for 5 over x plus 1, it will be 5 times the natural log of the absolute value of x plus 1. And then finally, do not forget the constant on the end. And there is the value of this integral, having used partial fraction decomposition and Heaviside's cover-up method. Now this next example is about as easy as the previous one. Again, the degree of the numerator is less than the degree of the denominator. And so let's just go ahead and use the Heaviside cover-up method. And then we're going to learn the general method where we equate coefficients. And the general method is often something you have to use if the Heaviside method will not work. The game now, again, is to break up 1 minus 3x over 2x squared minus 3x plus 1 into a partial fraction decomposition. So we've got 1 minus 3x, and the denominator factors into 2x minus 1 and x minus 1 pretty readily. I'm going to just show this a little differently this time. We're going to keep the integral intact and just go down vertically. If we let x be 1 and we cover up x minus 1, we'll get 1 minus 3 in the numerator, which is negative 2. And the denominator will be 1, and so that will give us a negative 2 over an x minus 1. And then if we let x be 1/2, the 2x minus 1 gets covered up, and so we'll get 1 minus 3/2, which is negative 1/2. I'll just write that down over here for a moment. And then x minus 1 will also be negative 1/2, and that's 1. And so we're going to get plus 1 over 2x minus 1. And now our integrand is rewritten as a sum of fractions. Again, you'll note that the denominators are linear factors of 2x squared minus 3x plus 1. We can readily show, or just anti-differentiate readily, I should say, and get the following: negative 2 natural log of x minus 1 plus 1/2 natural log the absolute value of 2x minus 1 plus c. And so this is the correct answer right here. And so I'm going to rewrite our integral again. Let's see, it's 1 minus 3x over 2x squared minus 3x plus 1 dx. We are going to take the integrand, 1 minus 3x, over 2x squared minus 3x minus 1, and we're going to we'll write the factored form. And then we're going to do this. We're going to use a little symbolism here. We're going to say we know we need a partial fraction where it's something a, let's say, over 2x minus 1 plus something else, b. Assume a and b will be numbers. And since we've done this problem already, we know that will be the case. How are we going to solve for a and b? Well, we can see that if we multiply everything by 2x minus 1 times x minus 1, we will get the following. We'll find that 1 minus 3x is equal to a times x minus 1 plus b times 2x minus 1. As we go along here, let's see what this looks like. we're going to do a little distribution, and we'll get ax minus a, and we'll get 2bx minus b. And then we'll bring the x's together. We'll get a plus 2b times x, and we'll get, I'll just say minus, actually I'll just say plus negative a minus b, like that. We can line things up here, and we can see that this negative 3x, well, and this a plus 2b times x tells us that a plus 2b must be negative 3. And then if we line up the 1 with the negative a plus b, we can see that negative a minus b, that must be equal to 1. And that's 2 equations and 2 unknowns. To rewrite this as a plus b equals negative 1, and then I'm going to bring it over and let's solve this system. We'll use elimination here, and I'm going to subtract the bottom equation from the top, a minus a, 2b minus b, that leaves us with 1b, and negative 3 minus a negative 1 is negative 2, so we know that b is negative 2, so a minus 2 must equal negative 1, and when we add 2 to each side we see that a is 1, and now we can rewrite a is over the 2x minus 1, and so we're going to put in a 1, and then b is over the x minus 1, and b is a negative 2. And so our integral should look like this. And if we go back up to our earlier work, we see that we did have a 1 over 2x minus 1 and a negative 2 over x minus 1. This next method, we're going to need one more little step along with what we've been doing already with PFD. And again, we do have a quadratic over a cubic, so the degree of the numerator and the degree of the denominator have the right relationship to carry out this method. So again, we want to rewrite our rational function. 4x squared plus 13x minus 12. Let's just start the factoring right now. We can see that there's an x in each of these. That's our GCF. So we have x times x squared plus x minus 6. And so now we have 4x squared plus 13x minus 12 over x times x plus 3 times x minus 2. We can see that we will need something over x, let's say a, something over x plus 3, we'll call that b, and then something over x minus 2, we'll call that c. And again, we will multiply both sides here by everything in this denominator over here. So we multiply both sides by that. I'm just going to put a little asterisk here to save some writing. You would normally write that on your paper if you're a teacher like me who likes to see students show their work. It's always a good idea. So this is going to lead to the following. The left side here is the numerator, 4x squared plus 13x minus 12. And when we multiply a over x, x will divide, it will leave the x plus 3 times the x minus 2, which is the x squared plus x minus 6 if we expand it, because we can see it's up here already. For b, we're going to have plus b times the x plus 3's divide out. We'll have x times x minus 2, which is x squared minus 2x. And then we'll have plus c times x plus 3, which is x squared plus 3x. And now at this point, we're going to plug in terms and see what results. Let's let x equal 0 first. And if we let x equal 0, we'll see that the x squared and the x are nothing, and we get negative 6a. And then we get b times 0, so that's nothing. And then c times 0, that's nothing. So we get negative 6a. And on the left side here, the 4x squared plus 13x minus 12 becomes a negative 12. So negative 12 is negative 6a. Divide each side by negative 6, and we see that a is 2. Next, let's just use a positive number. Let's use 2 because x minus 2, if x is 2, 2 minus 2 is 0. So that's another 0 of one of these factors. So we'll let x equal 2. And this time I will do this in the right order, left to right. And we put in 2 for x, and 4x squared plus 13x minus 12. We'll get 4 times 4, which is 16, plus 13 times 2, which is 26. That's 40, and 40 minus 12 is 28. And then on the right side, this may be a little more work. Let's see. X squared, that's 2 squared is 4, plus 2 is 6 minus, oh, that's 0, so 8 times 0. And then b is 2 squared minus 2 times 2. That's b times 0. And now we're just going to get a c term here. It's going to be 4 plus 6, that's 10c. Well, I thought something didn't look quite right. It turns out that when x is 2, the left side is 30. It was 26 plus 16, which is 42 minus 12. And that's what is equal to 10c. And so from that, we see that c is 3. Now we still have to find the value of b. To do this, we're actually going to use the values for a and c that we already have. And let's just plug those in first as we do this. And so the left side, of course, is still 4x squared plus 13x minus 12. And for a, we've got 2. So this is 2x squared plus x minus 6. And then the b value is still b. This is x squared minus 2x. And then the c value is 3, so we have 3 times x squared plus 3x. Now, when we let x be negative 3, let's see what we get. 4 times negative 3 squared, that's a 36. 3 times negative 3, that's a negative 39. And then we have the minus 12. And let's see, over here we've got 9 minus 3, which is 6, minus 6, which is 0. I'm writing down a little bit more this time, you may notice, just to be careful. And negative 3 squared is 9, and that's 9 plus 6, which is 15. And then over here, plus 3 times x squared, that's 9. And then 3 times negative 3, 9 minus 9, that's a 0. And so from this, we are seeing that we've got a negative 3 minus, so that's a negative 15 equals 15b, which means b is negative 1. And now we can write the partial fraction decomposition. So our integral will look like this. It's 4x squared plus 13x minus 12 over, let's see, what was that original? X cubed plus x squared plus x squared minus 6x. I believe that's right. Let me double check. X cubed plus x squared minus 6x. Good. Dx. And now we can rewrite this integral with the partial fraction decomposition. So our a value is 2, and 2 goes over x. Our b value is negative 1. And that goes over x plus 3. And our c value is 3. And it goes over x minus 2. Like that. And so now we can go ahead and anti-differentiate, and we will get, for the 2 over x, we'll get 2 times the natural log of the absolute value of x. And we'll get minus the natural log of the absolute value of x plus 3. And we'll get plus 3 times the natural log of the absolute value of x minus 2. And then, of course, the constant. And there's our answer.